Thank you. So yes, this is going to be a three-part presentation. It's going to be interesting because yes, we took the control away from you. I also should tell you that these cookies are well deserved. There was a lot of pressure from Valentin and the organizers that we get this in time. They didn't realize that we actually had started already, so it's okay. So it's going to be a three-part presentation. I'll talk about the facilities, essentially La Silla, Paranal, and a little bit about Alma. And then Marina is going to talk about the operational aspects of all this, and Nando mostly about policies and how you would actually get time or how you ask for time. So most of what we're going to talk about is something that that was a little difficult to give that presentation or to prepare it because, as I say, everything that we're going to show you, you probably know. So this is a collection of the current observatories that we are running. There is La Silla in snow. I should have put Paranal in the snow. And then Jahnantor with Alma. So those are the three facilities that you can apply for time right now. This is what's coming. The ELT, Nanda will cover most of the ELT parts. So I won't dwell on this. This is just to scare people. If you actually lay it out, this was with cardboard several years ago. If you lay out the primary mirror, it takes most of the place back here. This was before we had the supernova standing there. And CTA is also on the horizon. The CTA South, the Southern Array, will be operated on ESO land, and we're partnering in that. So starting with La Silla. La Silla is a place that's on the current discussion. We keep on thinking about the future of La Silla after a great past, if you want. So the site as it is here is mostly what we would call now a science platform. So many of these hosted telescopes, as we call them, are placed there and are operating. So it's not what a journalist many years ago called a telescope graveyard. Okay, so it's not a telescope graveyard. It was not our favorite journalist. I just wanted to point out one thing that doesn't work. Ah, yes, here it is. Black Gem was just inaugurated. It's sort of starting to work, which is, of course, sort of a complementary thing for LSST, the Rubin Observatory. The two telescopes that we're operating on La Silla are the 3.6 and the NTT. We've decided this, I'll get back to this, but we've decided this years ago. I've given a presentation that must have been 15 years ago where I said we should dedicate telescopes to specific science cases, in particular our 4-meter telescopes. And if there's some people in the room who are part of the Astronet discussions. I've said this for 4-meter telescopes many years, well, maybe a decade ago, that the 4-meter telescopes need to think what they want to do in the future. And one option is to dedicate the telescope to specific tasks. And so that's what we've done. The NTT will have SOX next year. And so we'll have a presentation on SOX specifically. That is almost entirely dedicated to transients. It's already with PESTO, ePESTO Plus, whatever acronyms you use these days, it's already dedicated to a large fraction to transients. And the 3.6 meter now has a new instrument, NIRPS, since about a year. It's dedicated to radial velocities. And so those telescopes have large fractions, huge fractions of the time going into very specific science cases. Small instrument complement. This is the current situation on the VLT. That's the situation that we have now, 2024. I put a plus there because there's things like gravity plus over here. So the plus is the plus. So that's coming in these years. We have moons, which will show up on the mountain in the second half of this year. We have Foremost, which will show up on Paranal in the second half of this year. They will go into operations presumably next year. So we have a number of issues coming. Those of you who are alert observers will realize that we made a little mistake here. X-Shooter is actually on UT3 and Vizier is on UT2. So that's just, that was a misunderstanding by one of our instrumentation people. The other thing that I think is important that you see here is that we have, in addition to the 4 lasers that we have on UT4, which are operational already, we will get a laser, one single laser on every other UT, and that has to do with Gravity Plus, so that we can do the interferometry. But that also enables us to use AO, single conjugate AO, but to use AO on these other telescopes as well. I'm not going to go too much about this. The red ones are in operations. The yellow ones are coming. This is just the planning that we have right now for the VLT. VLTI. You can look at this at more pleasure if you want when the slides are going up. Just to be a bit more picturesque. So these are the various instruments at the different places. I do believe this is up to date. So we have a number of VLTI instruments, Matisse Gravity, Gravity Plus, Pioneer is on there. On UT2, we have Force 2 and CMOS, and Moons is going to go in there. We have Vizier, sorry, that's UT1. On UT2, we have Vizier, U as in Flames, X-shooter, Cryo-resistant Sphere on UT3, and on UT4, that's the one with the 4 lasers. We have Ares and Muse and Hawkeye. These are the instruments that are making use of the adaptive optics. And Espresso, that sits at the incoherent combined focus. This is just to give you an overview of what you can do from the ground. I did not include LaCie in here. This is really just the parallel instrumentation. And you see we cover from the UV back cutoff here, what the atmosphere allows us to do, all the way into the thermal infrared with Vizier. And maybe less of an interest to this community, but we do have options to go to very high angular resolution, VLTI, and we see with gravity what's possible, also with Matisse, what's actually possible when you go to very high angular resolution astrophysics. All right. Just to say something about the future, we have something that we call internally a VLT 2030 program. This is Antoine Méron, myself mostly, together with the instrumentation people, trying to set up what is coming, what's next. This is a slide to scare our managers, to essentially say, look, this is the age of these instruments in 2030. And I've marked everything in red that's older than 15 years. And so CMOS will be 17 years in 2030. UMIS will be 30 years old, Vizier 25, X-shooter 21, and Muse will also be 10 years, 15 years old. So you see that these instruments don't get younger. You have to maintain them, and you have to replace them. So the planning is, we had the first round, 2018 or 19? 18, I think. And out of that came Gravity Plus. So here it is. And Blue Muse, which we hopefully will start the phase A this year. Fingers crossed. And then we will have another round of discussions what the next instrumentation should be on the VLTI. I put in a few slides about ALMA. The reason being ALMA is open to TOOs. There's time domain science that should be done, that can be done with ALMA. Maria Diaz-Trigo, who's the ALMA program scientist, is quite keen that we actually explore the time domain. She's just written, there was a conference they had at the EAS last year, and she's written a small article about this. So I encourage people to think about ALMA as well. Okay, this is not just there for nothing. So Maria gave me a couple of examples. So this is not 170817, that wasn't detected with ALMA, but you can actually see short gamma ray bursts. Here, this is a real detection. So you actually can see short gamma ray bursts with ALMA. And so that's certainly something that will be interesting to look at. This is probably dust formation in a supernova. This is something that gets more and more attention. We had a beautiful time series of supernova 1987A, the dust formation in the supernova, but also in the ring. And so this is also something that ALMA is going to be really strong. And as a last example, this is an observation. This is mostly to show you how important it is to cut across the electromagnetic spectrum to get an SCD. So the ALMA contribution is one amongst many other contributions. This is going from X-rays all the way to the radio, and ALMA, fills in that millimeter sub-millimeter gap. So this is pretty much what I wanted to say in terms of the facilities. As I said, Marina and Nanda will talk about more how you're going to use these facilities. But we're offering now telescopes from 4 to 40 meters, okay? Or if you include VLTI, from 2 to 200 meters in terms of resolution. I think as an observatory, that's quite unique. And so that allows us to go from micro arc second resolutions to, I put here arc minutes since we removed some of the survey telescopes that we had. So that's essentially the field of view that we have. We do have optical near infrared sub-millimeter access, or our community has access to this. And a lot of that has been used and is being used for follow-up observations of multi-messenger detections, or also other wavelengths. The operational mode, which is going to be covered by Marina, I won't dwell on this. The other thing which I believe is interesting that we shouldn't forget is that over the years, the VLT is now operational for 25 years. In April this year, it's going to be 25 years of operations. The NTT archive, data archive, is a bit older than this. So over these 2.5, 3 decades, we've built up quite a large archive. It's not, a survey archive. Some of it is surveys from the imaging and the spectroscopic surveys that we've done with our telescopes. But there's a huge amount of data in the archive that is accessible. And as soon as you start looking for things that go bump in the night with LSST, for example, you will be going back to these archives and see what happened there before. This is yours. I don't recognize this anymore.
Thank you. Thank you very much. So I will cover a little bit more on the operational aspects of how we use the facilities, or rather how the community uses the ESO facilities. And in that respect, focusing on the transients follow-up and the need for fast reactions. In terms of how the community uses our facilities, of course, everything comes through proposals, through requests for time that ESO then operates or allocates, and then operates the observations, takes the observations. So the unpredictable events can come through director discretionary time, and this will remain also in the future. Nando will talk more about how the future time allocation will evolve. Predictable events can come through proposals for generic science case. Typical cases, gamma ray bursts, supernovae, cataclysmic variables that go into outbursts, and targets that need some time sequences or specific action on a specific night. And in that sense, we have observing modes that are soft, so-called soft and hard target of opportunity. So more than 48 hours after the trigger, the observation can be done within the next few days, or has to be done very close to when the trigger is received by the observatory. Rapid response mode is interrupting the ongoing observation and really goes straight to the telescope. And the key to enable this is to have a large fraction of the time in service mode. And service mode then offers also the flexibility to put in different types of observations, either specific single target observation on specific target, or to link the observations in time links, or to group them, or to concatenate them because one needs really back-to-back certain types of observations. So all of this has been developed over the past years, not specifically for LSST, for time domain, but really to enable the community to use our facilities in diverse ways. Once the proposals are accepted, the so-called phase 2 starts, where the observations need to be prepared. And in that case, for target of opportunity or RRM, generic OBs are prepared that can then be triggered very quickly. Everything is checked and everything is ready such that there is no failures when the actual action needs to start. And for the service mode observations, we have developed these scheduling containers that short-term scheduler at the telescope can pick up with algorithmic way and decide what is the next best observation to take. This includes time-linked containers and also possibility of having nesting where we have concatenations of the observations, science and calibrator, typical example, in some time-linked series. So this opens up essentially the transient sky for the community. The transient sky for the ground-based observatories, for community observatories where classically people would go to the telescope and observe, were complicating, and with operational models and this flexible scheduling, we have enabled and actually have quite a lot of different time domain observations, from planetary transits to supernova to outbursts, cataclysmic variables, or novae, etc. There is quite, well, whether it's large or how large is the target of opportunity fraction, this depends on, of course, the preferences. For some communities, this is too much, for others, it's too little, but we have the flexibility in the policy to adjust to that. And we have implemented this rapid response mode to act on gamma ray bursts when this science case arose. In addition to this, we have also systematic archiving, so which is something that Bruno already mentioned, where once the interesting science target is found, one can go back to the archives, find all the previous data, and build on that as well. Specifically for the triggering of target opportunities, this is just some screenshots of the tools we have for our phase 2 tools, where a template observation will be prepared. The tool offers planning. It offers automatic generation of the finding charts. It is also accessible via an API, such that one can actually program the observations, and the time accounting is done via the Nightlog tool, where we are also further implementing some changes such that this becomes more automatic and more transparent for the observers. The triggering itself is done through the same tool, where these template OBs are essentially updated, and trigger message is then sent to the staff on the Paranal Observatory, who then take the observations. And this can be decisions on which observation to take will depend, of course, on how urgent this target opportunity is, whether it comes as a hard TO, soft TO, RRM. Rapid response mode was developed in 2007, I think. Actually, it was developed by an ESO fellow who was working on gamma ray burst science, and who really was keen on getting to the target really fast. So essentially what we are offering on a number of instruments is a mode where there is a server polling continuously for incoming ASCII snippets of codes that are telling the telescope, hey, you need to go to that position and start the observation. In that moment, the trigger is sent via an ASCII file to the FTP server. It interrupts the ongoing service mode or visitor mode observation and loads the RRM observing block. This starts some sound alerts in the control building, which can be pretty scary for the first time when you see it. It gives a pop-up to the operator and gives the possibility to abort. There is a countdown because if somebody is at the telescope at that moment doing some whatever, fixing something, the telescope can move and hit the person. I mean, you don't want to have that, but you can simply say, okay, go preset. And in that moment, the telescope decides whether it needs to change the focus, change the instrument, or if it's already on the instrument, it just goes. The ongoing observation is read out such that whatever can be saved is saved, but this is not the priority. The priority is to go to the next target. And then, so in this way, the observations can be done within 4 minutes. You can be on target from the moment that the trigger is sent. The further follow-up, if one needs additional actions afterwards, can be done via TO or just normal time-linked observations. One example of a campaign with a lot of time critical transient observation is for the gravitational wave, optical counterpart of the gravitational wave 170817. This was a special event. I think everybody, I would say that the whole world was super excited about it, and everybody really jumped on it. There were already programs prepared to look for these electromagnetic counterparts, several of them at ESO, but also there were dedicated additional programs that were triggered, and really there was a lot of action. Essentially, ESO put in place almost all its telescopes and a huge number of instruments. All the data went to the archives and were public. So this is the list of instruments with the wavelength ranges that at ESO that were used to try to detect. Some of them did not detect the counterpart, but for example, VISTA was among the first telescopes that found the electromagnetic counterpart, among the first 10, not the first. And thanks to its ability to very quickly scan huge areas of the sky, and X-Shooter made a very amazing series of spectra where the evolution of the kilonova could be followed. More than 5,000 scientific images and spectra were taken, more than 115 hours of observations over a couple of weeks on 14 instruments, 7 telescopes. In addition to these special events, and these special events, you know, the army moves, everybody just starts doing that, talking about that. But this is not sustainable. We are talking about LSST follow-ups, transient follow-ups, where things are working in operation, need to work in a sustainable way, need to be organized. For that, there are different ways to do that. At ESO, there are long-term monitoring programs. There are programs that follow single target, like Bruno's favorite target, 1987A, where essentially almost every instrument has observed 87A. Here we have some pictures from ALMA on the top, and then a series from HST and NACO, images of the evolution over a couple of decades of the ring and the structure of 87A. There are programs for the monitoring of the QSOs for measurement of the H0. There are surveys like Vista Magellanic Cloud Survey or VVV survey for the variable objects in nearby galaxies or in our own galaxy. Araucaria project led by Chilean colleagues that established different types of distance indicators. And we also had calls in the past for the public imaging service, public spectroscopic service. Example here being public spectroscopic survey. So PESTO followed then with PESTO Plus, ePESTO Plus, etc., which has, we'll hear more about it in a dedicated talk, followed transients over the past 10 years with typically 90 nights per year. All of this data go to the ESO archive. This archive has been upgraded and is fed now also more and more with reduced data, curated data products that are reduced with pipelines that are verified, certified, etc., and so homogeneously processed. It has also discovery possibility, it has programmatic access, and it can be used to tackle different science questions. It already produces, based on the archive-only papers, it already produces about 1/4 of the papers that ESO telescopes produce. In addition to this, there are coordinated observations, and here there are two examples. One example is where a gravitational wave, after this first excitement, the first discovery of the electromagnetic counterpart, it became clear that this becomes a much closer reality. There will be more such triggers. ESO took an effort to organize the community. There was a workshop, more or less like this one, where the community working in this specific field was invited and discussed how to best progress in the future for the follow-up of the gravitational waves. And this led to a single VLT proposal by the entire community, by the so-called ENGRAVE collaboration, and that has a clear priority because it has been selected through the official channels. The other example is where community organized itself. PESTO, follow-up of the transients, specifically supernova, but also red nova and other transients went on. There is X-ray community that is also polling time through XMM also, and specific projects. And of course, there will be more information in the coming talks today and tomorrow. This is a slide that actually Bruno picked up from Stephen Smart that shows how the follow-up goes. Not every follow-up goes to every telescope, depending on the brightness, depending on where the trigger comes from, one needs to choose a different telescope. ESO offers a number of different possibilities for that. And this is my last slide. This is just to emphasize again the fact that ESO offers different opportunities, flexibility, and unique facilities. Some facilities that are not thought of immediately for maybe some of the transients, but are becoming more interesting. Interferometry is used for searching for stellar mass black holes from microlensing. This also requires target opportunity follow-up, and this is an exciting science case there. With Gravity Plus, interferometry will become able to go to much fainter targets, so may provide some unique science there as well. And in terms of complementarity, of course, there is a slew of facilities that ESO offers. So I'll stop here.
Thank you, Marina. So ESO is a service organization. So we build and operate big telescopes. And while Marina, Bruno, and myself were preparing this, we thought that today, rather than telling you things, it would be nice for us to listen to you. Of course, I do understand that after our presentation, there may be some discussion, but we warmly invite you, I encourage you, maybe during one of the breakout sessions, to discuss about what you would like to have from us. So we are here to provide services. And this is why in my presentation, I will basically go through the time allocation process at ESO, so that at the end you have basically all the elements that tell you what we can do, and then you come back to us and tell you, I would like to do this, and that. So, of course, we call for proposals. This is what we do at the moment. We call twice a year. Yearly, we process of the order of 1,800 proposals. So in 2009, actually, we processed more than 2,000 proposals in a year, which arguably is the largest number of proposals for any facility, astronomical facility, both ground-based and spaceborne. So we have 2 review channels in place since Peer 110. So we introduced the distributed peer review to flank the panels by cutting by 50% the loads on the panel, because as you will see one of the next slides, some of the panels had more than 100 proposals to review, which is an overload. And the cut-in time here is 16 hours, which was the median of the time request at ESO for the VLT, which means that you distribute 50-50 the proposals, but still you keep 15% of the time is administered by the DPR and 85% goes still to the panel. So the panels manage most of the telescope value at ESO. This fraction may change in the future, because we don't know actually what will happen once we deploy the ELT. Is the number of proposals going to double, or is it going to decrease? So we don't know that for a fact. But DPR is there to help in case we are flooded by proposals. Then we will change the fraction. We'll get more to it into the DPR. Now, for getting the stage of the discussion, so that you have an idea what we are talking about. So we get of the order of 900 proposals per cycle. Submitted by 700 different PIs, from including 3,500 COI, so this is a third of the IAU community, from 50 different countries. So this is the name of the game. And the typical request is 3,200 nights per cycle that we get asked to put on our telescopes. We don't have all those nights, of course, or better said, we don't have all those telescopes, so we typically put in a third of all of that. A maximum of 15% goes to GTO time. Now, this is the so-called Brezachet plot. It gives you the perspective, is the history of proposal submission at ESO since 1977, when most of this audience was not yet in this world. And you see there is a linear growth. Then around period 55 and 60, there is the so-called Big Bang. So the NTT was shut down to put in the new software testing for the VLT. Then there is the breathing before the jump. The first UT comes, the VLT, you have a big jump. Then it keeps growing as the UTs come in, and we reach the peak in period 100, and in period 84, when a shooter was deployed. That was the highest peak. And then we had another Muse Sphere Camo, second generation instruments, or second highest peak. And then we have the third, which is actually in the end, the second highest peak, the period of the first pandemic event, where we extended the proposal submission deadline from 4 weeks to 8 weeks, and this has produced a second wave of proposals, so the highest peak. But the message there is that we got stabilized at around 900 proposals there. There may be slight index, so we got the saturation in the community. We believe this is what it is, so we reached the capacity of the community to submit proposals. There may be some disillusion component, meaning that you submit a lot, you get rejected, and then you give up. And maybe there is a little bit of a sign. And as I said, in period 84, when a shooter was deployed in that year, we processed more than 2,000 proposals in that year, more than 2,000 proposals. So as you can see, this is now the distinction between the sites. As you can see, the VLT stays constant. What came down is the other sites. Last year, we decreased the number of telescopes. We lost, so to speak, Vista and DST are not administered by us at the moment. Apex also went away. So just to say that VLT is indeed, and VLTI are indeed constant. This is the size of the community growing up. So we reached 4,000 users. This is distinct users in a semester. Then the pandemic came. But in parallel with that, we deployed the fact that now all COIs have to have a user portal account. So it's not that the pandemic killed the difference, so 1,000 users. No, it's just that we, more or less in parallel, we deployed that you must have an account in the user portal, and that explains the jump. Now, the load on the panels has been very, very high. You see typically 80 proposals per panel with peaks out of 100 proposals. And then once we introduce DPR by construction, this produces a drop. Why I'm mentioning this here? Because the quality of the reviews, of course, is expected. They get the same amount of time at half of the proposals. And as I said, we can tune this thing. Now, interesting for all of us here, what can you apply for? What is it that we already have in place at ESO so that you know if there is anything missing, and then you come back to us. And this is a proper time for doing that because we are preparing for the ELT era, and we have deployed a large number of changes, and this is the right time to do that. Normal programs, this is 85% of the proposals that we get. It's below 100 hours. Monitoring, and they extend only to one cycle. Monitoring programs can extend up to 4 semesters and up to 100 hours. Then we have joint programs. We have an agreement within the XMM, Newton satellite, and ALMA. Recently, we deployed the joint VLTI ALMA joint venture. There are total time limitations. For instance, at the moment, we can allocate up to 50 hours on ALMA telescopes, and ALMA can allocate up to 50 hours of VLT time. And with XMM, we have 80 kiloseconds time that we can allocate on their facilities. And of course, we have the large programs. There's a discussion there. Large programs now are typically more than 100 hours. There is already discussion in the time allocation committee as to whether we should increase this limit, say, to 200 hours or more, because now the projects become bigger and bigger. And then, of course, as Marina said, we have the Director General discretionary time with a rolling deadline, so you can submit at any time, which is to cover risky cases, transients, and all of that. Now, all of these programs, all of them, and this was changed in the recent years, all of them feature target of opportunity runs. So for all of them, you can apply for target of opportunity time. As Marina has shown you, I'll give you some more detail. We have different flavors of TOOs and also the rapid response mode. And this, I think, is very important. It's something you should consider. It's the surveys. So ESO offers with irregular calls that are issued upon discussions by the VLTI program scientist and the director for science, and then an agreement with the director general and the SDC. We issue a call. I'll give you more detail for large allocations running for typically 5 years, so 10 semesters, dedicated with lots of time on purpose. We had the Gaia, for instance, the ESO Gaia surveys, which was extremely productive, and I'll give you more details. But it's something that you should really, really consider, because that is something that we can trigger if there is enough interest in the community. And of course, calibration programs, I grade them out because they're not really interesting for you. Now, target opportunity flavors, a little bit of more detail. So those are manual triggers, as Marina said. So you have already a program pre-approved. You have already the observation blocks in there. You just sent in the coordinates. And if your reaction time is less than 2 days, then more than 2 days, you go for a TO or soft. And then this gives the observatory also some flexibility, plus or minus 1 day. This is what we try to guarantee. Hard, again, is a manual trigger, but it means that you go for a hard when you need a reaction time of less than 48 hours before, or when you need some specific execution time. And as Marina said, you have the rapid response mode, which is virtually immediate. Okay, we guarantee a 4-hour reaction time. And in most of the cases, what Marina portrayed, this is what happens. Now, this is an interesting point because we have all of this machinery, but in the end, we only get in the policy, we had 5% limit, maximum amount of target opportunity time that we could allocate on the telescopes. And the rationale at the beginning of operations back in 1998 was that TOs and RRM are going to impact the observations, and therefore you want to limit them. Of course, in the LSST era, this would have been a killer. So Bruno has already made that step several years ago. This limit has already been taken away from the policy document. There is no limitation. It is up to ESO, and this can be set at the call for proposals. We don't need to consult with council to change that fraction. And at the moment, the interesting thing is that, however, the request we get from the community is small, of the order of a few percent of the total time. And we typically allocate over the VLT and the VLTI, something like 3% of the total time, of which only between a half and a third is triggered. Of course, not all TOOs trigger in the end because they don't have the candidates. So we are talking about a fraction of the level of 1%, which is less than the Director General discretionary time every semester. Now, I do expect, people in the transient areas do expect that this fraction during the LSST era will grow potentially dramatically, and that's an area where we need to work. Managing 1% of TOs is easy. You don't even need to put it in the schedule. It's within the noise. You can reserve some random time across the semester, and when the triggers come in, fine. They will not make a dent in your execution queues. But if this fraction goes up to 50%, then that's a different story. And how do we decide that? The only deciding point, the criteria, is what the community needs to have. And this is where we need you. So I do expect, we all expect, and it is reasonable, that this fraction will have to grow. How we cope with that operation is a separate story. But it's the community that first has to come to us. So upcoming changes are important. For 60 years, we have been calling for proposals every semester. And at the moment, we are probably the last largest ground-based facility calling per semester. So we will move to a yearly cycle probably in 2025. Of course, by doing this, you will say, yeah, but you're going the wrong direction because you lose time, the reaction time, your duty cycle is going to be a factor of 2 larger than it used to be. Yes, and to counteract that, we will introduce what we call the fast track channel, which is akin to the fast turnaround channel of Gemini, to compensate for the loss of the duty cycle. The plan is to have a substantial fraction of time, so 10, 20%. We'll have to see what the demand is from the community. And then you can submit a proposal for that for special and important cases, which could not be submitted at the yearly cycle, anytime during the semester. It will be reviewed through the DPR, so fast. You don't need to convene a panel, so people will get the proposals, review them. The idea is that the total reaction time is going to be between 4 and 6 weeks. We'll see how we do that. And the rationale is that you want to cover with that important cases. You don't want the community and the organization to lose all these important cases that may come up after the yearly cycle deadline. This, of course, will imply a redefinition of the DDT that will only be dedicated basically to transients. That is what is, and maybe this will also require a reshaping of the thing if the number of transients going in through that channel will explode, because that reviewing those proposals will also be an interesting thing that we'll have to look into. Now, I could not resist today of citing this thing here for the next change that we have in mind, because it's quite controversial. And this was pointed to me by Teresa Yerabkova, one of my collaborators at the Observing Programs Office. This is a page, 2 pages from the Arthur C. Clarke book, Rendezvous with Raman. Okay, of those of you who have already looked at it, you will find this citation inside that there is a professor emeritus, Olaf Davidson, who is the chairman of the SAC. You can call it the TAC, is a similar thing. But the extraordinary meeting of the Space Advisory Council was brief and stormy. Even in the 22nd century, no way had been yet discovered of keeping elderly and conservative scientists from occupying crucial administrative positions. Indeed, it was doubted if the problem ever would be solved. What it is interesting is that if you go back to the other page, Clarke says he was much interested in objects smaller than galaxies and never bothered to conceal his prejudices. And though he had to admit that 90% of his science was now based upon observation from spaceborne instruments, he was not at all happy about it. No less than 3 times during his distinguished career, satellites specially launched to provide one of his pet theories had done precisely the opposite. So why am I citing this? Because so far we go through the classical panels, which we all know they tend to be conservative and give the time to, you bet the money on a sure project. And as we all know, evolution comes through mutation. Okay, in some cases, mutation can kill you. You get a cancer through ultraviolet radiation or gamma rays, whatever. But in many cases, it brought us from 4 legs to 2, in some cases. It's not necessarily a step forward, one could argue, but in general, mutation leads to evolution. And so you need to have some spike in this. And for this, the time allocation working group, which was convened almost 10 years ago for the ESO 2020 prioritization exercise, had recommendation number 8, which is spelled out here: introduction of a high-risk channel for the submission of high-risk, high-gain projects requiring significant amount of time. And ESO should consider a high-risk channel and ask people, even outside of the field, to give an opinion on that. So this is something we are considering. It's a very controversial thing. The Director General at the moment is very much in favor of this. We'll have to see what the committee says, but this may be interesting for all this discussion here. So this, I say it again, is for large allocation, not just give me 1 hour to try something. It's a major thing that would lead, if potentially would lead to something major. It's not easy to police. The discussion is controversial, but I thought that I would throw this in if you want to discuss this as part of one of the items in the breakout rooms. Now, public service. I think this is fundamental. I think this is the most important bit for this audience, for the time allocation part at least. So they are rare. They are called for very specific purposes. This is by definition. ESO, in the form of the Director for Science, issues a call for letters of intent in the community, so that is the formal process, so that we understand whether or not the community is interested in doing any of this. So if you are interested, that is the way to go. Then the community responds, possibly, with a number of letters. There is an internal review, and then a list of potential PIs author submitters of letters of intent are contacted and asked to submit formal proposals. This goes to the public survey panel. It's a special panel that ESO convenes for this purpose. And this makes a recommendation to the Observing Programs Committee, who is the body in charge of making a recommendation, finally, to the Director General for the implementation. And then, once they are approved, the teams are asked to provide a survey management plan and blah, blah, blah. And then the survey is implemented and typically lasts for 5 years, which is a time scale that it comes comparable to the LSST Live. And of course, in a survey, you can think about that. It's up to you. What do you put in? Is it target opportunity? Something that is related to the follow-ups of the targets found by LSST and so on and so forth. And this presentation is already public, I think, so you can click, and there are links to the details for that. Now, of course, I've been talking about existing facilities. So you have seen from Bruno the suite of instruments, the VLT with the 4 lasers, UT4 and blah, blah, blah. But a giant is rising. This is a real thing. It's not a computer simulation. This is a computer simulation. But not what you're going to see soon. So this is a very big telescope. When you go outside and you look at the assembly hall, the diameter of the assembly hall is 39 meters. It's exactly the diameter of the mirror. Now, I am also glad to say that a few days ago, the first segments made to Chile. So this is not anymore a piece of paper or a drawing in a computer like this one, but it's getting real. So it's coming up. So the first light is supposed to be in 2028. Okay, the LSST will be already in operation at that time, but still there's going to be another many, many years in which the telescope, the ELT, will be operational together with the LSST. So it is also time to think about that. Now, the time is running, so I will go quickly through the instrumentation of the ELT, and for more details, of course, you can refer, there are lots of pages for that, and of course also to the presentation. So I will rather go quickly to the instrumentation. Just to make a clear statement here. So what you see here is the NASMIT platform of the ELT, one of the two. It is as large as a tennis court, just to give you an idea. Right? So it's a very big thing. So I'll go through. So we'll start with one instrument at first light. It's going to be called Mikado. It's a multi-adaptive optics imaging camera for deep observations. This is how we will start it. So you get here, I will not go into the details, it's going to be too long, but basically it covers between 0.8 and 2.4 microns. What is interesting is that next harmony will come, and this is something that I'm always very excited about the field of view of these instruments. So it is exactly the opposite of the LSST. So the largest field of view is 10 by 10 arc seconds, and the smallest one is 0.6 by 0.8 arc seconds. So this is the instrument which will deliver a diffraction limit of a 40-meter telescope. It's going to be 5 times better than the JWST, provided that everything works. So, and then you have mosaic, then you have a multi-object things, wavelength, resolution, and blah, 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 and METIS. So I will skip this one. This is a summary table with the numbers for the timelines and the start of operations. I'll give to your thoughts when you want to consider. Now, just of course, I mean, there's a reason to be proud about that. It's just the sheer power of having a large telescope which reaches the diffraction limit. There's a comparison between HST, JWST, and what you can reach with Mikado, same images. It's a dream, of course, at the moment, but we are all dreaming in that direction, and hopefully this will be right. And also in terms of numbers, this is what you can, doing stuff down to magnitude 30. Okay, signal to noise of 5 in 5 hours integration time. So we believe we are ready to respond, but most important today is that we are ready to listen. to listen to what you need so that we can think ahead and start in discussion with the director for science, the next VLT and VLTI program scientist and the ELT program scientist so that we can put things together. So I asked Michele Cirasuolo, who is the ELT program scientist, what will be the ELT capabilities in terms of responding fast. And it's quite surprising. So they have planned that, okay, they will offer target opportunity, which is not entirely clear, it's planned. The telescope will slew between 1 and 3 minutes from any place to the other, which is a big thing. This is a very big thing. It's like half of a football field of mirrors that, slews in one direction or the other. For the same instrument, they claim they will be able to, say, start acquiring the target in 3 minutes, at most in 3 minutes from the moment you have sent the preset. Now, this grows to 5 minutes if you have to switch instruments between one platform, one tennis court to the other, rotating one of the mirrors, it takes 5 minutes. If you have to, if it is in the same platform, if you have to swap the tennis court, then it takes a quarter of an hour. So this is probably the longest reaction time. So if it's going to be difficult, say, to change from one instrument to the other side and have a reaction within a minute if you want to observe the same target. I don't think this will happen, but just to give you an idea. Now, this is all nice and beautiful. However, this is a 39-meter telescope that needs to phase 900 segments, and the way this phase depends on the configuration of the stars that you have in the field. Therefore, the signal to noise you will reach will depend on what you are observing. It's not just where you point. There are points in the sky which you will never be able to observe, for instance. There are very few, but there are. So from a technical point of view, the operational point of view, this will require that when you send the trigger, you know already, of course you know where you are pointing, but there's going to be a tool on the fly which will tell you at trigger time whether or not you will be able to reach the performance that you are expecting. That may not be the case. If you have only one very faint star within the reach of the waveform sensors, then you may not be able to do the observation. So most likely this is the only complication of the whole thing. On this, then I will hand back the floor to Bruno for the final summary of the presentation.
All right. Well, thank you. So this is just summarizing what we said before. I think most of this, what you see on this slide, is what we talked about. There's a way of thinking about big observatories, and this is just put down here. What you often have is you have what we would call the flagships. So you have these facilities that everybody knows about this. Everybody, even the people in the street, hopefully will know what the ELT is. And so you have these flagship facilities. In right now, we would argue this is ALMA and VLT, VLTI. The ELT will take over that role, at least for the optical and the infrared. And so we will have ALMA and ELT in a few years as flagship facilities. The VLT will maintain its unique capabilities, among which is the large instrument complement. So first of all, you have typically 4 beams. You have 4 instruments that can work simultaneously. If you want to do a very rapid transient, a soft gamma ray burst, or a gravitation wave event, it's an advantage if you have 4 instruments doing this simultaneously, whereas the ELT will just have to, one after the other. And we just heard, if you have to change platform, that's another 15 minutes lost. So the other thing which VLT has is the interferometry. There is a difference between 40 and 200 meters in resolution. There's a difference in limiting magnitude too, but still there's the interferometry. And so that's something that we believe is the core of the Paranal operations as well, the Paranal facilities, and the fact that we have an operational model that is going to be really helpful for these. We've talked about the dedicated telescopes, NTT with SOX, 3.6 meter with HARPS and NIRPs, and foremost on VISTA. Okay, so the 4 meter telescopes that ESO operates are all dedicated to specific tasks. We didn't talk very much about VISTA and foremost because foremost has, I can't remember, 16 or 18 surveys defined now. No, there's more. 18. Okay, 18 surveys defined right now that will run over 5 plus 5 years. I think that's the idea. So we will not offer that telescope anymore to the community. We've done that through these surveys that Nanda described. La Silla is maintained for the moment as a platform for hosted telescopes. So there's still projects that people bring and would like to have put up on a site that is actually quite good. We have the archives that we mentioned. So that's that. And then this is the last slide. This is just to bring this back home. There's a place out there in the desert. Some people don't like this, but you know, there is Paranal, there's Armazones. The Cherenkov telescope array is going to go in between. What you can see here is a photovoltaic plant that is going to supply the day power to these places. There is Alma in the north, and there is La Silla in the south. So this is the complement that you can choose from if you want to apply for observing time. So thanks very much.